So we're jumping straight into number 2 for this problem. We're still in the same student task statement, but I'm going to put some of the teacher's notes on the side in the classroom so you guys know where I'm getting these points from, okay? So if you guys see me plotting the ratio of 2 to 3, 3 to 7, 4 to 12, you know where that came from. Because when I'll read number 2, it said it wants us to plot the values from the table on the class coordinate plane. Then plot the class data points on your coordinate plane. So basically, the goal of this activity was you were supposed to work on your circles with you and your partner. The next group was supposed to work on their different set of circles, and the next group was supposed to do the same, and so on and so on. And then as a class, we were supposed to come together, plot it all on the graph, and we should have, basically explored what was going on with it as a class. But of course, we're at home, so I'm going to try my best to explain this so you guys can understand this. All right, so the first coordinate point is 2 to 3, or the first order pair. The first order pair is from 2 to 3, which was the diameter and the estimated area that we did with each other. So I'm going to plot it right here. I don't want to put it exactly on 2, and I want you guys to make the observation, and I'm sorry if I'm moving too fast, but the x-axis is representing the diameter, the y-axis is representing the area. If you don't know what the x-axis is, here's the x-axis, and here's the y-axis. Okay, so... and then I want you to know that this is counting in sets of even numbers, and the y-axis is counting in tens. All right. So the diameter is from 2 centimeters to 3. Well, the area is 3 centimeters square. So what I want to do is I don't want to go all the way up to that first line because that represents 10. I want to kind of hover as close to 2 as I can, but not actually touching it. Okay, so then the next point is from 3 to 7, which I want to be a little bit right underneath there. This is the 3 line mark, but going up. All right. So then the next point is 4 to 12, which I want to be right above that 10 mark, and so on. All right. So then I want to do 5 to 19, which I want to be right underneath that 20 mark. 6 to 27. Ooh, that's a big jump. Okay. 6 to 27. I want to go underneath that 30 mark. All right. And then the next one is 7 to 38. Wow. It keeps jumping. Then the next point was from 10 to 78. So we're going to go all the way up there. So this is 100, 90, 80, and that 78 should be right underneath here. Whew, that was a jump. Okay. So then the next one will be 12 to 108. Now, of course, I don't want to plot all those points on the graph. I'm going to stop right there. But what do you notice? Okay, this is, I guess, what's going to help us answer question 3. It says, in a previous lesson, you graphed the relationship between the diameter and the circumference of a circle. How is this graph the same? How is it different? Okay, so let's look at this. All right. It says that both graphs of circumference and areas go up as the diameter increases. Okay, so it's kind of going up. All right. Well, not kind of. It's going up. All right. So that's one thing that they have in common. But this graph, however, is going up rapidly. Okay. And I'm going to draw a red line just to give you an example of one that's gradually going up and one that's rapidly going up. If you notice, right, this was the jump. So it went from tiny going up, going up, going up, going up, and then it just jumped. is going to keep jumping. As a matter of fact, if I would have plotted the last pair, which was 20, it would have went to 312, which would be all the way up here. Okay? So it's been rapidly increasing. All right? Now, I know this may be from Unit 2 and so on, and we're in Unit 3 now, but do you think this would represent a proportional relationship? The blue line? Not the red, but the blue, or the green line. Do you think this would represent a proportional relationship? If you guess no, you are absolutely correct. This is not a straight diagonal line. And we can't even assume that it's projected to go through the origin. Okay? All right, guys. So if you have any questions about this student task or even questions about question number 2, please feel free to visit your manager's Google Meet session. And right now, I'll be moving on to the next question and the last question of the lesson. And I'll see you guys then.